Thanks very much for coming. Really appreciate your letting me share my DevOps journey. It's great to see some familiar faces from other groups in the Boston area. Okay, a little bit about me. I'm Senior DevOps Engineer at Wolters Kluwer. I'm an analytical chemist by education. I learned when I was in graduate school that writing device drivers was a whole lot more fun than actually doing any chemistry. I actually realized I didn't like chemistry. But I finished the degree and ended up working in laboratory and pharmaceutical software, some financial software. I've been with Java, working as a Java programmer, more or less for 20-some years. Back in the days of 1.0.2, if anybody remembers that far back. Almost 10 years with Jenkins and release engineering and DevOps. Wolters Kluwer is a global company that provides information software and services to healthcare, to tax, legal, and financial professionals to help them make more accurate decisions. We have offices in about 40 countries all over the globe, about 19,000 employees, and we're headquartered in the Netherlands. I work in the healthcare division, so we provide technology and clinical solutions to improve patient care and increase clinical effectiveness. And the users of our software, of our products, are doctors, nurses, pharmacists, allied health professionals. Some of the business objectives, and I'm going to focus on the last two. We knew that we were going to be acquiring other companies that had similar business models to ours, or complementary. So the last two are integrating the systems of acquired companies was going to be a big thing. Driving increased productivity of technology groups within clinical effectiveness was also going to be key. More specifically to the reason why we're here, so the Jenkins challenges we faced, we had about 600 jobs manually maintained via the user interface. Now I know that's not new to anybody here. People have done that for a long time. There was no version control. People would enter scripts into their job configurations. There was no version control of either the job or the script. Lack of consistency in jobs, low scalability for expected growth was huge. Anti-agile, nothing new here. As I came on board about 2 years ago, I thought I was already well versed in the value of continuous delivery and those concepts, such as the importance of version control. It's foundational. I mean, for those of you who have read Continuous Delivery, which I've read a couple of times, the authors talk about everything in the book assumes that you're already doing version control. You know, if you're not doing version control, don't bother reading the book, put it down and get into version control and then go back to reading the book is kind of how it is. The values of automated testing, refactoring, early feedback, reliable releases, nothing new here. We've been hearing about this value for a long time. So we sing these praises to others, but do we eat our own dog food? When we, as a DevOps community, when we write software to put these values into place for the business, do we use these principles ourselves? So what I want to describe here is a development of a Jenkins pipeline of pipelines application, discuss how CD principles can be used for internal DevOps software like this, and mainly to stir ideas of what's possible. How many people are aware of what Job DSL is, the Jenkins Job DSL? Okay, all right, great, a lot. But for those who aren't, or as just a quick recap, it's a way to create jobs via a groovy DSL. So you can write code to create a job. So rather than going in and saying create job and configure it via the UI, you can do it with code. So as a simple example, you can create a job that does something like compile your code and set the schedule of when you want it to run and do all that with code. So a Jenkins C job, what is a Jenkins C job and how does it relate to this discussion? So it's a single Jenkins pipeline job, the new Jenkins pipeline job, and its purpose is to create many folders, views, and jobs. So with that as background, what Job DSL is and what a C job is, let's move forward. So I've started out single-handedly, but I'm transitioning this to others. Over the last 2 years, developed an application called Enterprise Jenkins Automator. It is a Java application, and it also runs as a C job. What it does, currently over 500 jobs are created using this EJA application, none using the UI. It has framework aspects that perform the CD functions, which is the primary thing I want to talk about this morning. The application contains job types that perform, for example, and these are only examples, Testers work output that they have placed into Git. Testers create small JSON snippets of their work, and the application reads those snippets and creates jobs, all automatically, all dynamically. It does inspection of Git branches, again, all automatically, wakes up, reads branches, creates jobs, and several more. Technology stack that was used. Groovy, Gradle, no stranger to people that have done Java development, Gradle and Groovy. It uses a Jenkins, the Job DSL plugin, and it runs on CloudBees Jenkins master. And of course, the EJA code itself. So it runs and it creates all the Jenkins job on our CloudBees Jenkins master. And they actually do end up running on a Kubernetes, on an OpenShift Kubernetes cluster. So what we found very useful, and when I started this, I kind of wanted to not think about security very much, or roles, permissions, kind of seeing that as an afterthought. But it's proven to be more time consuming than I ever realized. So there's a huge benefit in having our operations center, which controls all the roles, permissions, SSH keys, users' passwords, across all of our Jenkins masters. And right now we have 3, and we're looking to expand that. So each Jenkins master can be viewed as an environment, a testing environment. So we have production, but we also have test and QA and so on. Pictorially, what does EJA do? And again, I don't really want you to focus on what this application does, but think about how you might be able to apply principles in your environment. So the application is versioned. And this is part of the rapid delivery, continuous delivery process and traceability. It's versioned and it wakes up every hour. So there's a C job that runs every hour. It wakes up, it reads Bitbucket, it takes all the team's output, whether they're microservice repositories that have the branches read, or tester output that I just said had small chunks of JSON and create Jenkins jobs from that. And it creates the jobs, including all the folders and including any views. So what you end up with is a nested view folder hierarchy. This is the folders here, and the jobs. And you'll see some, I don't know if you can read that, but the highlighted parts are the different branch names that get created. We just talked about what it does. Now let's talk about the framework features, which is really what got me jazzed about doing this work over the last 18 months or so. So it's a Java application, so it therefore has unit tests. For example, when it runs, the unit tests check that all the job folder path construction is correct. Because if you've done something wrong, typically there'll be spaces or nulls, or things won't be right in the job folder paths. So it checks those. We have custom regex pattern rules. If it's a branch, it should have this kind of version. If it's master, it should have that kind of version. A little bit complicated, so it goes into a unit test. We have integration tests. Verify that the jobs exist on a testing server. The job snippets that come out, the chunks of JSON that the testing team produces, when this EJA runs, it actually hits the testing server and makes sure that all those things are there first. There's no point in creating a Jenkins job to build something or to test something that's not on the testing server. Job cron syntax. So if the code has specified a cron syntax, verify that it's legitimate cron. There's been multiple times where people leave off one of the parameters. Well, this will catch that right away before you even put it on the Jenkins server. Again, these are things that run on a developer desktop. You can run this on a developer desktop before you even put it on Jenkins. And lastly, and this just got put in a couple months ago, is all the produced pipeline syntax for all the jobs get parsed. It's amazing how many times the errors end up being simply mismatched parentheses or braces, and to wait until the job runs to find that out is painful, right? So part of this running checks all that ahead of time, parses all of that, all those files ahead of time. And again, on your laptop. This is not on Jenkins. It tests them all on your laptop. Okay, more framework features. So when the job runs, if it runs in the Jenkins test master, all the jobs are configured one way. For example, the Git tags are not pushed to the Bitbucket, for example, or maybe the Nexus repository, the binary repository, is a test repository rather than the real one. And another example is the jobs on the test machine, guess what, don't have any schedules on them. We don't want the test jobs to be running. So none of them have schedules. Continuous delivery. merges to master are picked up, tested, and released automatically. So as soon as there is a job, as soon as there's a commit to master, picks it up, runs all the tests, runs all the unit tests, and finally runs the C job to create all the jobs. So a little quick kind of a side story here. I remember we were getting ready to do a production rollout, and the coordinator came up to me and said, hey, can we shut off? You know, you've got all these Jenkins jobs running. Can we shut them off? Can we shut them all off? And at first I thought, oh, how am I going to do that? Well, as it turns out, it was really about 30 minutes of work to just set a global flag. And before I set the schedules, I check this global flag. And if it's true, I allow it. If it's false, none. So what they do now as part of the procedure is you do a one-line change in Bitbucket that says false, and then all the job schedules get turned off. Okay, so let's talk briefly about the code highlights. I'm going to show you specific examples of the code, but just to kind of walk through the pseudocode. So for each folder, I add the folder to the list. All the folders have to be created first. For each job type, and the job type is simply, there's an inheritance hierarchy and a series of job types. Right now there's about 6 or 8 different types. And for each job type, I create all the job definitions. A job definition is simply a POJO, a plain old Java object with things like the schedule, and the log frequency, and the script itself. Very simple, plain old Java object. For each job definition, set the Job DSL closure. It's probably the only tricky thing in the whole operation, and I'll show you the code, the entirety of the code. It's not much. That's kind of the amazing thing looking back, is how little code does so much. For each job definition, create a file in a folder structure and parse the pipeline DSL code. Now, as the Jenkins C job, for each job definition again, create the job. And then verify that the job exists. So after the C job runs, there's a little snippet of Groovy API code, the Jenkins API code, to just verify that all those jobs are actually there. Because it's surprising how in the early days when we didn't know what we were doing, it said it created the job, but then it would silently fail. So it was helpful to have some code to verify that they existed. So there's heavy use of enumerations, and I'll go over why that is and why I think it's okay. Here's an example of just getting all the branches. Just a small amount of code that just gets the branches and gets the valid branches, because people should be free to create whatever branches they want, but in terms of this application, I only look at these particular types of branches. The microservice values are all kept in an enumeration. For example here, what Bitbucket project they're in, what types of jobs I want to create for each microservice. Some of them are Maven driven, some of them are Gradle builds, some of them are using a newer technology called JGetVer that we're using, and which jobs do we want to create for them? So one parameter sets that. This has to do with the version series that we want to use for releasing, job schedule, JUnit path, default, where are the JUnit tests, or whether we have any, and then emails on failures. And these are only most of the parameters. They couldn't all fit on the screen, but just to give you an idea. You know, again, the idea is not this application, but how much can be done in code. That's really what the takeaway is. So here's the job definition I was telling you about earlier. That's just a plain old Java object. So path to the job, build on schedule, cron schedule, days to keep, job description, the SCM URL, if it's a pipeline from SCM job, although almost all of the EJA jobs are just pipeline scripts. They are not backed by a Jenkins file. We lay down the entire pipeline as a script. Pipeline script goes right here, optional parameters goes here. That's pretty much it. I think there might be a couple more, but those are essentially it. That's all it's in a job definition. So now here's the closure creation, which is what's needed for the job DSL. And literally this is it. Again, it's a little more than that, but I was too worried it wouldn't quite all fit in the slide, but this is 80% of it. So you can see here that you create a closure, and this is all specific to the job DSL syntax. So it's all well documented, but this is it. Once you have your job definition, you can create your closures that way, which is what gets passed into the job DSL. And the actual job creation is these few lines of code. Once you've got your list of all your job definitions, you walk through the list and you create your jobs. Talking about folders from code, you can actually create, it's not that hard, create folders from the code as well. So when the application runs, it creates all these, this is just a small sampling. It's actually fairly deeply nested structure that we've set up. You can also create views. So we have views. And the views, people maintain themselves. The test automation lead would come to me and say, well, I want another view that has this and this kind of pattern, and can you do that? And I'm like, well, yeah, create a pull request and go change this file and submit the pull request. So encouraging people to be part of this and socialize the code. That's a key part of this, is socializing the code. So the application treats code and configuration the same way. Now, it made me think about why they were ever separated. Historically, you separate code and configuration, at least to a large extent, because it's a lot harder to change the code. People get afraid. Oh my God, I don't want to touch the code. I'll just change the configuration. So I'll make sure that all the configuration is separate from the code, so I don't have to, oh God forbid, touch the code. But what if there was such solid testing in place that people weren't afraid to touch the code? What if the unit tests and the integration tests were such high quality that we're not afraid to touch it? Is there any reason not to combine them? In fact, might there be huge benefits to keeping them together? Because the reality is, even though you think you're separating the code and the configuration, a lot of times they have to change together. I mean, it's classic database technology and Java code, right? You want the configuration elsewhere, but it's actually a lot harder to do. So keeping them together, what it lets you do is leverage groovy data structures. So you can model your data, your specific application, you can model using Groovy, or Java. You can use lists, and you can use classes, and whatever makes sense for your application. So let's go over how an EJA workflow is. So if I'm an EJA developer, I go to a $, again, on my laptop, and I run Gradle test integration full. And it iterates through all the job types. These are the job types. And this would be generic. I mean, this could be, the job type could be something specific to you, to your application. It tests the defined jobs. Again, these are unit tests. Verifies cron syntax, verifies some of the testing jobs. It exports all the jobs and their folders into the Gradle build folder on your laptop. It's a build artifact. So you can actually look inside and see all the jobs in the folder structure. And then does syntax parsing, really, of all the pipeline DSL. I set up VS Code, which I'll give a shout out to the VS Code developers. They have an awesome product. I never thought I would use a Microsoft product, but I am. It's an awesome product. It really is. It's a really nice editor. It's somewhere in between an editor and an IDE. So I use that. I can do everything locally on my machine, create this build folder, and here's the Jenkins root. Here are all my folders, and I can look at the resulting pipeline scripts that get generated, again, on my desktop. So what it allows is continuous and collaborative delivery. So typical things that get asked for, I've got a new smoke test. I want to refactor the code, and we'll talk more about refactoring in a minute. I want to change the job schedule. I want to alter a Jenkins pipeline. I want a new job type, completely new job type. I want to trigger a new job. I want to add a folder or a view. I want a new microservice. All of these kinds of things are handled through Git pull requests. Nobody ever goes onto a Jenkins job and clicks configure. Doesn't happen. And currently there are about 6 people now that are starting to become EJA developers. And when I say developers, it could be something as minor as making small adjustments to schedules, but they're familiar with how to run this on their own desktop and look at what's produced. Refactoring. Refactoring happens a lot, and that's good. That's a good thing. It allows, after 18 months, I look back at the code before I started doing this, and I'm like, wow, there's not really a whole lot of code out there. And it's because of the constant refactoring. And what enables the constant refactoring? Automated tests. Knowing you've got automated and tests in place lets you refactor easily and confidently. The other feature I put in is a single file of all the pipelines. So all 500 jobs, all the pipelines get splatted into one humongous file. So as I make my refactoring changes, I can run it again and do a diff of the 2 files. Did anything change? If it did, I didn't do my refactoring well. So refactoring, again, for those who aren't that familiar, is the art of improving existing code. So you don't change the functionality, you're just changing how it internally is written. So putting it all together. So this is now our pipeline of Jenkins pipelines. So each commit to master, every commit to master triggers unit tests, integration tests, parse of pipelines, and creates the jobs on our test Jenkins. And if they all succeeded, it verifies that the jobs were actually created. It applies a release version, a tag, onto the code, and now runs them on the production instance. So this happens with every commit. Every commit to master goes through this. And again, once the version has been written, that version wakes up every hour to create new jobs dynamically as people commit changes into Bitbucket, as all the development teams and the testing teams do their work. Eating our own dog food. The belief in trying to, as best as possible, applying CI/CD practices to DevOps software itself. If we think it's good for end user customers, it should be good for our internal customers as well. Infrastructure as code. All the jobs, folders, and views are created only via code. It's scalable, easy to add new jobs. It's often a one-line change. It's amazing how many times I'll make a change and it's just one line. It's adding a new version or adding a new repository. It's easy to add new types of jobs. Again, inheritance hierarchy, base class has core functionality, just add a new subclass. All aspects under Git controlled, socialized. Many people help evolve EJA. People make suggestions, improvements, and at least a couple of people, we've hired a couple of new co-ops, and they are getting familiar with how to do this. And they like that it's code because they want to code, right? I mean, developers want to code. So that's the other cool thing about this. It appeals to people that like to code. And the world is moving into code, so much higher visibility of changes. That's another good one. Everybody sees what's different. Oh, these jobs got added, or oh, that cron got changed. It's very visible. No hidden in job configurations. Simple rollback. Something went wrong, jobs got miscreated, just change this version back to the previous version and run the C job again, and presto, all the jobs get created correctly. Or just do a git revert head. Revert the most recent commit and run it again. Future, what do we have planned? More testing. More testing. It's always about more testing. More code and more testing. I haven't done this yet, but ideally, I'd like to know that when the C job runs and creates all the jobs, that it actually goes through each job type and triggers the job on the test instance. So it would actually run through a pipeline. On the test box, the pipeline is configured to be non-destructive and just do things that are tests, not real. More functionality. We are expanding our use of Red Hat, OpenShift, and we're going to be building and pushing Docker images using Kubernetes and OpenShift. So a lot of these jobs are going to be added to EJA in the near future. We're starting that really now. So kind of lessons learned, or if you wanted to roll your own, if this approach sounds interesting, suggestions are to automate the release process early. I mean, get something running from start to finish as soon as possible. Incremental changes. Make the changes as small as possible. If it takes you a long time to make one-line code change, something's not right. So change the process so it's easy to make a one-line code change. So you can make incremental changes. It should be common that you're making small changes. Socialize the code whenever possible. If somebody comes over and wants you to make a change and the code is in Bitbucket, send them a link. You can actually, if you're in GitHub or Bitbucket, you can actually send them a link to the exact line number. This is the line that has to change. Send them a link and say, please change this and submit a pull request. Refactor, refactor, refactor. I've said that before, but it's hugely helpful. And test, test, test. It's amazing how many things actually can be tested. Summary is it's a pipeline of Jenkins pipelines that supports our business in a constantly evolving manner. It's been very helpful.